In this video, I'll talk about performance metrics, performance metrics, which is a classification problem. Okay, classification problem. Now, what I wanted to do here is I wanted to take a data set. Simply, let's say I have two features called x1 and x2, and I also have a y actual and I have y predicted here. Okay, y predicted. Now based on my data set, I have the values of y actual and y predicted. Let me just use this data set for a better explanation. Okay, let me write here 0 0, have the output called 1 1, and the output 1 1, then 0 1, and let's say I have 1 0. Okay, now I have this data set based on the features x1 and x2. I have got the output, right? Now I have got the output. Here I have y actual and y predicted, right? Now let's build a confusion matrix. Let's talk about a confusion matrix before we get into this problem statement. Here I have two rows and two columns. Okay, two rows and two columns. Now let's say I have one 0 here, 1 and 0 here, and here it is actual prediction, sorry, this is an actual value, and here it is a predicted one on this side. Okay, predicted. Now let's say this is true positive, false positive, okay, false negative, and true negative. So this is our confusion matrix. Now what actually this confusion matrix is, we'll see a little bit later on, but for now let's understand this here. So based on this problem statement, what I'm trying to write here is, I'm just trying to draw the same confusion matrix here. Okay, now we wanted to find the performance of this data what we have taken here. Okay, now what I'm trying to write here is 1 and 0, 1 and 0. Let's say this is an actual and this is our predicted. So from this data set you can just observe the values right here. Now actual is 0 and 1. Okay, now let us say actual is 0 and predicted is 1. How many zeros and ones are there? This is 1. Okay, 0 1, and this is 2. So here what we get is 2. Now let us see actual one and predicted 1. Okay, let us see how many we have. 1, 2 and 3. So we have 3. Now let's look at the actual one and the predicted 0. Actual 1 and the predicted 0, I have only 1. Okay, 1. Now the actual is 0 and the predicted is 0. Now we have here 1. So now we have a data here like this. Now we wanted to find the accuracy, and this is the confusion matrix. You can see it right here. And this is a confusion. I'm using confusion matrix here. This is a confusion matrix. Okay. Now what I'm trying to do here is I wanted to find the accuracy of this data set. I mean, this is a classification problem. Now I just wanted to find the accuracy here. Okay, now let's see what will be our accuracy here according to this data set. Accuracy will be, and here the formula will be the summation of these two, true positive plus true negative divides by true positive plus false negative plus, and the total whatever that is there in the matrix. So this is actually the formula. Okay, now what is true positive here? 3. What is true negative here? 1. 1, right? Divides by true positive is 3 again, and false positive is 2, and false negative is 1 plus 1. Now what we have got here is it's around 4 and 3 4 5 6. Okay, now it will be like around it will be something around point 0.57. Okay, now we have got 57% accuracy here. You can see it here. According to this formula, we have got 50%, 57% accuracy, right? 57% accuracy. Now let's look at in different direction. Suppose if we have an output, suppose if we have got an output here, suppose our output is having 900 zeros, okay, 900 zeros, and similarly we have, like, out of total 100, total 1000, we have got zeros 900, and we have got ones 100 here. In this case, this will be having an imbalanced data. So in imbalanced data, our predictions will go very much wrong. Data set. This is an imbalanced data set, right? Suppose in other case, if we have a data out, if our outputs are having around zeros 600, and let's say ones are about 400, and this would be probably a balanced data, a balanced data. Now when we have zeros 900, when we have outputs zeros 900 and outputs ones 100, then our data is biased. Data is biased. That means if we apply this for an accuracy, okay, if we apply model for this data set, if we apply a model for this data set, okay, this model is having everything zero here, right? Now it will definitely give an accuracy like 900 divides by 1000, which will be around 90% accuracy. So definitely this will be a problem for if we have imbalanced data, you need to be very careful to just judge the right one. So for this, what we have here is, there are three methods we have. The first thing we are talking about, we'll talk about precision. First thing we'll talk about the precision. Okay, precision. And the next thing we would like to talk about recall, and the third one is F score. Very important. See, now let us talk about the precision. In precision, what it is going to happen here, let's try to write our confusion matrix here. It will be very clear for us to understand. Let's say we have, according to our confusion matrix, it is true positive, okay, false positive, and false negative, and true negative, right? So what actually here, let me just put here 1 and 0, 1 and 0. So this is a predicted, right? This is predicted, and this is here it is actual. Okay, now in precision, what is happening here, we have a formula called, our main focus is like the true positive, on the true positive and the false positive in the precision. Okay, in the precision we are going to concentrate on this. I'll take another color. In the precision we are going to concentrate on this. Okay, now the formula for precision will be true positive divides by true positive plus false positive. So this is the formula for precision. Now, and the formula for recall is true positive divides by, now we will focus here for the recall, true positive divides by true positive plus false negative, right? Now this is a very important, right? Because we need to understand actually here what is recall and what is precision. Actually, uh, suppose from all the classes we have predicted as positive. This says what this actually says is, from all the classes we have predicted as positive, how many are actually positive? So precision should be high as possible here, right? This is the precision case. Now in the recall case, what we are trying to have here is, from all positive classes, how many we can predict correctly. That means recall should be high as possible, and this is given by an equation, this TP divides by TP plus FP. Right. Now, let's talk about accuracy. Let's talk about accuracy. So, from all classes, whatever we have here, from all classes, positive and negative, how many of them we have predicted correctly? So, here accuracy should be as high as possible, right? Now, let's talk about this F score. F score generally gives a formula. We can just write. We have some different formulas here. Let me just define F beta formula first, which can be written as F beta, which can be written as 1 plus beta whole square into precision into recall divides by beta square into precision plus recall. Okay, now here whenever we are putting beta is equal to 1, that means it becomes F1 score. F1 score. Okay, now here what is going to happen? 2 into precision into, I wanted to just use P and R instead of writing the whole, and P plus R. Now you can see it here. This is something like 2xy divided by x plus y, which is harmonic mean, right? Which is harmonic mean. Now, for various cases, we are going to use the values of beta here. Now, if we wanted to check for beta is equal to zero point 0.5, then we can just use again the same thing. We'll just use 1 plus zero point 0.5 whole square into P into R divides by point, because beta square here it is, so 0.25 whole square into precision plus recall, right? Sorry, into P into precision plus recall. Okay, now here if you use beta is equal to 2, if you use beta is equal to 2, you will get F2 score. So we have different scores here, F1, F.5, like F.5 score and F2 score. So it all depends on you can see here what is important for us. In different cases we are going to have these false positives and main important thing here is, for different cases we may get like false negative is far greater than false positive is far greater than false negative. So based on this you will decide the precision here. Based on this you will decide which will be better. Okay, so this is about a performance matrix for a classification problem. Do watch some videos as well as do study by your own. Probably you will get some idea about this. In this video, this is it. We'll see you in the next one. Thank you.